We're used to seeing beautiful images of deep sky objects, but many things are so faint as to appear only as a blur of light in even our most powerful telescopes. Fortunately, we can still learn a great deal about these objects by studying their spectrum. Let's fly into Ursa Major, home of the Big Dipper, to look at a few objects observed by the Sloan Digital Sky Survey. Just by looking at this star, we can tell that it's blue. But if we look at the star's spectrum, we can find out exactly how much light is being emitted at every wavelength. This star's spectrum shows dark absorption lines due to hydrogen in the star's atmosphere. If we convert the frequencies of light to frequencies of sound, we can listen to the spectrum. It sounds like this. This red star is much cooler. Its spectrum shows broad absorption bands due to molecules in the star's atmosphere. The spectrum of this white dwarf looks very much like the blue stars, except the lines are broad. This broadening is due to the immense gravity at the surface of the star. White dwarfs are made of incredibly dense material. 1 teaspoon of white dwarf material weighs more than 5 tons. The spectrum of this elliptical galaxy shows the combined light of hundreds of billions of stars. We can detect absorption lines due to hydrogen, calcium, magnesium, and sodium, but we don't see them where we would expect them. They've been shifted to the red. This redshift is due to the expansion of the universe, stretching the light as it travels towards us. By measuring the amount of the stretching, we can determine the distance to this galaxy. This galaxy is 140 million light years away. In addition to the light from the stars, the spectrum of this dwarf galaxy shows bright emission lines due to hot gas in the galaxy. This spectrum sounds like this. The redshift of this spiral galaxy indicates that it's 450 million light years away. Bright emission lines tell us that this galaxy is still actively forming stars. This object is a quasar. Quasar spectra contain broad emission lines. These emission lines are produced by fast-moving gas clouds accelerated by the quasar's supermassive black hole. Quasars are extremely bright, and that allows us to see them to great distances. This quasar is 21 billion light years away. This quasar is one of the most distant objects ever observed. The bright emission line we see in the red has been shifted all the way from the ultraviolet. When we look at this quasar, we're looking 90% of the way back to the Big Bang. Images are great. They show us how beautiful the universe is. Spectra, they tell us how it works.